In this video, we're going to take a look at molecular compounds, both the composition of molecular compounds and how molecular compounds are formed. As their name suggests, molecular compounds are comprised of molecules. The noble gases do not make molecules, even though molecules are formed from nonmetals when they come together to then obtain a stable noble gas configuration. Well, since the noble gases already are stable, they're not going to combine with other atoms, and we find them as what we call monatomic elements, because again, they're only one singular atom. One molecule which you may be familiar with is water. Water consists of two hydrogens, one oxygen, and we see it as a liquid at room temperature, because molecules are their own separate entity. They don't combine together and make larger and larger molecules like we saw with ionic compounds. Because of their sharing of electrons in completing their octet, they don't then share with other molecules. Ionic compounds, where you transfer the electrons and we get ions, they just keep adding more and more and more together because you get more and more oppositely charged particles coming close together, electrostatically combining. But covalent compounds are going to share those electrons. They make just one molecule together, and then that is separate from a different molecule. So many elements make molecules in nature. Even though you'd think, looking at the periodic table, there's not that many different nonmetals, so there can't be that many different molecules in which they can be formed. But unlike ionic compounds, where they make maybe one, if they're lucky, two different compounds between them, if it's a transition metal, these nonmetals can combine multiple ways, and you get multiple different compounds from the same two elements. So a molecule is an electrically neutral, just like they were electrically neutral with ionic compounds, group of atoms that again held together by covalent bonds, not ionic bonds this time. They're sharing of electrons. We see this in oxygen. Oxygen makes a molecule, again because of its 6 valence electrons, which is very unstable. It wants to gain 2 more in making it very reactive. In nature, you're never going to find just a singular oxygen atom floating around. We see them again in a diatomic molecule, where there's 2 oxygens sharing 2 pairs of electrons together, giving them a complete octet, making them like a noble gas, and you see it as O2. Probably you've seen O2 written many a time when you've done out the respiration or the photosynthesis process. You've written out O2, not understanding why that happens to be, but it's because, again, oxygen being so reactive will form a molecule with itself to give it a noble gas configuration. So it gets called a diatomic molecule. There are 7 in total elements that exist this way in nature. Again, because of how reactive they are and how unstable they are, they will not be found by themselves. So 6 other elements are hydrogen, nitrogen, fluorine, chlorine, bromine, and iodine. So these 7 in total, they always make a diatomic molecule. There's a couple different ways in which you can remember which elements make the diatomic molecules. On hot nights, I bring fried clams is one way in which you can do it. Also, if you look at the periodic table, starting with the number 7, nitrogen, because there's 7 of them, if you make then a 7, so nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, make out a 7 in a pattern on the periodic table, and then just remembering hydrogen in the top left. Each of these atoms of these elements, again, have a very unstable electron configuration, so they don't want to exist on their own. Especially the halogens with 7 valence electrons needing just 1, so they will share 1 pair of electrons between them to complete their octet. A molecular compound is made up of different molecules that we've already discussed. Again, water, H2O, is its own separate molecule, and then in a glass of water, there's billions upon billions of water molecules. They don't combine together like those ionic compounds because of their ionic charge, making them add more and more and more ions together. They're their own separate entity. And because of that, they have much lower melting and boiling points than that we saw of ionic compounds. Ionic compounds have super high melting points. You only find them as crystalline solids at room temperature, where molecules could be a solid, a crystal solid like you think of sucrose, but also could be a liquid like we see in water, or a gas like we see with oxygen. So hydrogen, again a diatomic molecule which we see, well, when 2 hydrogens come together, you think, oh, well, they have 1 proton, 1 electron. And those protons, when they come together, are going to really start to push apart and repel. However, they also have this 1 electron. And those electrons are then going to be attracted to the nucleus because they're opposite charge, and they're going to share the one electron that they have to then make them be like helium. So now you have two hydrogens both feeling like they have two electrons, giving them a complete first ring like that of helium, making them more stable. And like ionic compounds and metallic compounds, we see that positive, negative, positive here between the proton, the electrons they're sharing in the middle, and then the proton of the other hydrogen atom. So you don't get the repulsion, you still have the opposite charges attracting, keeping it together. So a covalent bond is formed between different nonmetals. It could be the same nonmetal, it could be two different nonmetals, but because of their almost complete octet, they're not willing to give up their electrons. They're going to get into a battle over these electrons, and since both really want their electrons and also want to gain electrons, then there isn't going to be a transfer like we saw in ionic compounds. So the hydrogen, as we just saw, shares one pair of electrons to make it feel like helium. Two fluorines, as we discussed, again, 7 valence electrons will then share one pair of electrons between them, making them feel like neon. Oxygen, having 6, 8 in total, again, will share 2 pairs of electrons, making what we call a double bond, again giving them now a configuration like that of neon, making it now stable, completing its octet, giving it that 1s2, 2s2, 2p6 neon configuration. So molecular formula is very similar to that of an ionic formula. Molecular formulas tell you what different elements are made up in that molecule and how many of them there are. It tells both the different types and how many we see of each atom in that compound. Here, carbon dioxide, again, a molecule you're probably very familiar with from respiration and photosynthesis both, is made up of 1 carbon and 2 oxygen atoms sharing electrons to make a carbon dioxide molecule. Another important molecule is that of methane, CH4, the smallest of what we call a hydrocarbon. So carbon and hydrogen actually make many different compounds together, because carbon can string together with itself and make long chains of carbons. So the smallest level, CH4, is the smallest hydrocarbon we have. But then 2 carbons together, filling out with 6 hydrogens, makes ethane. Also you have propane, butane, octane, like in your car, all the way up to what we call wax, which is many carbons strung together, filled out with hydrogens, completing all of their octets. So again, it tells you how many of each atom there is within that molecule. CH4, 1 carbon with 4 hydrogens, just like that of H2O, 2 hydrogens to 1 oxygen. Or even, again, an ionic compound like salt, NaCl, 1 sodium with 1 chlorine.